Hello students. Today we will be working on lab number 2 exercise. This document is available on Blackboard. We're going to go through the various steps to help us understand how to do some of the Excel functions. So what the exercise gets us to do is go back to our exercise data that we created in lab number 1. So you should have something that looks like this, where we created a histogram, data table, and we have our data and some of the functions that we calculated previously. To save some space, we no longer need this, so I'm going to delete that and start working on going through this lab exercise. Step 2 gets us to calculate the mean, median, and mode. The function for mean is using the average, so we're going to go equals average. We have that function. We're going to highlight all of our data, close that bracket. There is our mean. We're also going to calculate the median and the mode, and those functions are just the same, equals median. And then the mode, because we're kind of thinking that the data will have more than one mode, if we just use equals mode for that function, we won't have any idea if there's more than one mode. So what we want to do is use the multi-mode function, which is right there. So we have the bracket. We're going to highlight our data, close that bracket, and Excel will only display one mode until we go back to that function window. You can do that by clicking on FX, and here is our different modes. So I have 6 different modes right there. So in your lab exercise you may have 2 or 3, you may have more, and you may only have one mode. So that's how we tell from the data if there is more than one mode. So we're going to cancel that. The first one is displayed there. So we're going to change the mean and the median to 2 decimal places as listed there. What we want to do here is determine how skewed the data is. Excel has a few functions that does this. For this intro course in statistics, all we're looking at is a difference between the mean and the median. So we get a value of 36.47. What we are looking at more importantly is whether it's positive or negative. My value is positive, so basically it's telling us that the data is skewed to the right. Step 4 is we want to go back to our data. We want to change one piece or one part of the data. So I'm going to unhide those middle columns. And we're going to change one of those pieces of data and see what change it has to the mean and the median. So what we're going to do is we're going to try to find that largest value. We know what it is. The largest value is 15,089. And we're going to replace it with a million. So getting that find and replace window is by using Control F, and we want to go into replace, type in the maximum value, type in a million, and then click on replace just once. Cannot find a match. Come on. Let's do that again. Control F, replace, 15,089. Find the next, there we go, and replace. And you're going to see it's right there. It's too big to be listed there, but there is a million. And let's see what happens to our mean and to our median. You'll notice that the median has stayed the same. The mean has greatly increased, and our data is now skewed more to the right. A much bigger number, obviously still positive. So if we go and use the Control Z function a couple times, we can get that back to the original value. Let's do the same thing with the minimum value. My minimum is 75.39. Control F, 7539. We want to replace it with negative 1 million. Let's see if this will work. Replace. Let's find next and then replace. There we go. So there is negative 1 million. You notice that the mean has greatly fallen, the median has not changed, and our data is now skewed to the left. It's a negative value there. So let's undo that, get that back to original. That's step 4, just a short little exercise in understanding that the median is not influenced by really small or really large values. Calculate, in step 5, calculate the variance. So let's do the variance over here. The function for variance is VARP, bracket, highlight all your values, close your bracket, press enter. I'm going to hide some of these in the middle. Now if you hide some, always hide the middle values because it still enables Excel to use those values. Standard deviation, the function for standard deviation, STD EVP bracket, highlight all your values, close your bracket, and there it is. Now just to reinforce the relationship between variance and standard deviation, if we were to take the square root, SQRT, bracket of one number, square root of the variance equals the standard deviation. Those values are the same. And just to verify it the other way, if we square the standard deviation using that symbol, that is shift 6, and we want to square it. So we're going to go equals, click on the value for standard deviation and shift 6 2 to square, and we will get our variance. We don't need those values anymore, just as a way to reinforce the relationship between variance and standard deviation. Step 6 has us calculating some percentiles. I'm going to enter them like this. It says calculate the 35th, 50th, 75th percentile, and the first quartile. Remember, the first quartile is the same as the 25th percentile. The function for percentiles equals percentile bracket, highlight all of our data, comma, a k value. K value is the decimal form of the percentile. So because I entered the percentiles as 35 and 50, I need to divide those by 100. And there is our 35th percentile, 10,697. Now if we were to copy this down, we would change it, the percentile, from 35 to 50 to 75 and to 25. But if we copy this down, our array would also copy down as well, and we want that to be held constant. So whenever you want something to be held constant, we're going to make it an absolute cell reference. Oops. By pressing F4 or by inserting dollar signs. So now, drag that down. Those are our percentiles. In Excel, really easy. On paper, 2 or 3 step process to do that. Now what we can also do is calculate quartiles. Let's do the first 3. The function for quartiles is just quartile bracket the array, comma the quartile we're looking at. We're looking at the first one. Close that, and there's our value. When we copy this down, our array value is going to change unless we make those cells have an absolute cell reference. And now we can copy that down. The cell array, the array data is not going to change its location, but the location for the quartiles is going to change. So one thing we should note here is that if we kind of color some of these in here, the median is the same as the 50th percentile, and it's the same as the second quartile. Whereas the 75th percentile is the same as the third quartile, the 25th percentile is the same as the first quartile. So on an exam or assignment, if I were to ask you to calculate the 75th percentile, you could calculate using a third quartile. Just something to keep in mind. What we also want to do is calculate interquartile range. Interquartile range is the difference between the 75th percentile and the 25th percentile, or the difference between the third quartile and the first quartile. It's the range of 50% of the values. Coefficient of variation is the standard deviation divided by the mean. And we change that to a percent. So I'm getting approximately 10%. So I clicked on, let's just double click that. I clicked on the standard deviation value divided by the value for the cell containing the mean. So thus, the coefficient of variation is useful as a relative value, basically to help us compare different data sets, the variation of different data sets. Now we want to change gears here and go into our data table. We're going to get rid of our histogram, move that out of the way. What we want to do in our step 8 is calculate a weighted average of the grouped data. Sometimes we're going to have a data table that looks like this, and we want to see what the weighted average is. We want to see what the average is. We don't have perhaps access to that raw data back in sheet 1, but we still, for whatever reason, need to calculate an average, and all the data we have is now presented in a data table. So I'm going to hide these two columns because all we need is the frequency and one more column, midpoint. The midpoint is the middle value between the lower limit and upper limit of each bin. So in this situation, the middle value would be 7,400. Our class width is 800. So to make this a little easier, if we enter the class width, whatever class width you have, plus the value above it, we will get the midpoint of the second class. And if we drag that down, we have now calculated the midpoint of each and every class. Second step we need to do is multiply across, multiply frequency and midpoint. We're going to call that perhaps just an FM column. Drag that down and copy that down. This column here would represent the frequency times the midpoint value. What we want to do now is do an auto sum. Click on that auto sum feature, hit enter, and there is the sum of the product of the frequency and midpoint columns. Now the grouped mean is basically now just taking a look at that, like the total of that last column divided by how many observations or data we had, and our grouped mean is going to be equal to 11,133.33. I'm going to bring in the mean, typing correctly here, that we've calculated previously. The raw mean, the mean of the ungrouped data, just for comparison purposes here. So the group mean is 11,133, whereas the mean of the raw data was 11,144. Not equal to, they won't be equal to because of the assumption that we make in the data table by calculating the midpoint.